Okay, sorry, I got a little interrupted there. So let's pick up where we left off. All the z-scores are converted to z-scores. What are the mean and standard deviation of these z-scores? The mean of the z-scores is 0, because if we were to add them all together, it would land right in the middle. The standard deviation of the z-scores, each standard deviation is 1, right? Is exactly one standard deviation over. So here's the middle, here's one standard deviation away, 2, 3, and these are all exact z-scores along the bottom. It's kind of an oddly worded question. Which student performed the best on the last test when compared with the rest of their class? Okay, so this symbol in the Greek alphabet means mean, and this one is standard deviation. So first period, there's a student, there was a student who, had a mean of 15, and the standard deviation was 2.4, and Adam scored a 17. So when I start thinking about this, I can tell that Adam is, Adam is not quite one standard deviation, because one full standard deviation would be 17.4. So he's he's less than one standard deviation away from the mean. Okay, so he's above, but he's not a full standard deviation. Second period, as a kid, Ben, who had a mean of 18, and he had a standard deviation there was a standard deviation of 3, but he got a 20. So I can tell that he is over one standard deviation away from the mean, because he got a 20. Oh no, he's not, because a full standard deviation again would be 21, and he's at 20, so he's also less than 1 away. Cindy, there's a mean of 13 and a standard deviation of 13.7, so one standard deviation away would be 16.7, and Cindy got a 17. She is actually greater than 1 away, so she's doing really, really well. Fourth period, mean of 17 for Dory, and standard deviation of 1.5, and she got a 19. So one standard deviation away would be 18.5. And then 2 standard deviations away would be another 1.5 away, so that'd be up to 20. So the question now is, who did better? Did Cindy do better? Or did Dory do better? So to solve this problem, what we need to do is see who had the bigger z-score. Exactly, because it seems to me that those two would be kind of close. So what we need to do to calculate this is you need to take the data point, so how the kid did on the test, and you need to subtract the mean and then divide that by the standard deviation. And when you do that, it's going to give you the z-score. So let's do that for each of these scenarios. So I'm just getting my calculator out here. Give me a second. Okay, so we're going to have the data point of 17, and we're going to take away the mean of 13, and we're going to divide that by the standard deviation of 3.7. So that's 4 divided by 3.7 is 1.08 for Cindy, and then for Dory, we're going to go 19, subtract 17 divided by 1.5, and that's 2 divided by 1.5, which is 1.33 repeating. So that's a bigger number than 1.08. Therefore, D. There are 3,000 students in your school. You surveyed 100 random students about their favorite food. 5 of them said salad. How many students in the whole school would you estimate, or would you say that salad is their favorite food? Okay, so we got 3,000 students in the school. We 100 of them. 5 say salad, so 5% of the kids like salad. But there's 3,000 students, so we need to go 3,000 times 0.05, which is 150 students. Okay, that's through 51. Now I gotta find 52. Okay, 200 people in the school were surveyed about their IQ, and the data is normally distributed. The average was 100 and a standard deviation of 15. How many people have an IQ between 90 and 120? Okay, so we need to go ahead and get the z-score of that, but first of all, let's take a look at Johnson over here. Johnson, why are you so mad? Huh? You all right? Okay, be a good boy. All right. IQ of 90. So let's get the z-score for the person with the IQ of 90. So we're going to take their data point, we're going to subtract the mean, and we're going to divide that by the standard deviation. Let's do that for the person with the IQ of 120. And let's see what each of these z-scores happens to be. So this would be negative 10 divided by 15, which is negative 0.67. And we got this as 20 over 15, which is 1.33, right? Yes. Okay. So I'm going to look up these on the z-score sheet and see what it has to say. Okay, so now we got to go to the z-score sheet. So I got negative 0.67. So here's negative 0.6, if you remember how this works. Johnson. And then 0.7, and then we just search across to where those two line up, which is right here. So this person has an IQ that is in the 25.14 percentile. So the IQ of 90 is 25.14 percentile. Person with the IQ that has a z-score of 1.33, they are here and here. So they're in the 90.82 percentile. So the IQ of 120 is in the 90.82 percentile. All right, so the question was how many people have an IQ between those two? Well, we'd have to go 90.82, and we would have to subtract 25.14, and that would tell us that 65.68% of the population has an IQ that falls in between those numbers. Question 54. Two normal curves have been graphed on the same axis. They have the same mean, but different standard deviations. Describe how the curves look. So they have the same mean, but different standard deviations, okay? So one, could be like this, and you'd have a mean in the middle. It's like 100, right? And then one standard deviation away could be like 110, and then it'd be like 90. And then you could have another one with a different standard deviation. That's a horrible bell curve. But it would be, that's a worse one. Sorry, I'm sitting down in a recliner right now. Okay, that's better. So let's say that this one was like 100. And then this one was, it's just like, it's more spread out. So it's like 120, and then it's 80. But they have the same mean, but you can tell that the curves just look a little bit different. 55. Data has been collected and a normal curve has been created. What's the likelihood that your data will fall 3 standard deviations outside of the mean? So we could just go to the bell curve here. 3 standard deviations away from the mean. That's the high ones plus the low ones. So that's 0.3%. And let's see how much I have left of this test. Is that really it? I think we may actually finally be done. Let me just confirm that by looking back here. Yes, we are there. Okay, if you have any questions or anything, or if you noticed a mistake there somewhere along the way, just shoot me an email or something. Thank you.